In the previous video,
we're going to look at some
formulas for
properties
integrals
of
of sine and cosine.
And in this
And
video, we're going to apply
these
that
integrals
to introducing
orthogonality
the
relations.
Fourier series of a function.
And basically orthogonality.
And we've seen in previous videos that in studying the heat equation, if your function can be written as a sum of sine functions, then we can solve the heat equation. But many functions cannot be written as a sum of sine functions. But it turns out that a lot of functions can be written as is in the context of vectors. It's when the dot product of two vectors is 0. As a sum of sine and cosine functions.
We'll see that,
and that's what we're going to look at in this. A lot of them will be 0. And vaguely speaking, because of that, they're called orthogonality relations. So the first one is, suppose the integral from negative L to L, and L is some positive number, of sine of k pi x over L, and k here is an integer. K is an integer. Well, this is actually an odd function. That you have a function, sine of k pi f of x over L is an odd function. And we know that when you integrate an odd function from negative L to L, you get 0. Can be written as a sum of cosine and sine. Okay. So why is this first? It's going to have some constant term, which I'll call a sub 0 over 2. So for a constant, it would just often be called c or just a sub 0. If you replace x by negative x, the reason we're going to write as a sub 0 over 2 here will be clear once we find the formula for a sub 0. There's the odd property. So suppose you have this plus a sum from n equals 1 to infinity of sine of some constant a n times theta, so then this n pi x over L would be like your theta, and then plus so you have a sine of negative theta that's equal to infinity of e sub n times, so that's sine of n pi x over L. So f is a combination of cosine and that sine. Shows that this function is an odd function. If you're familiar with linear algebra, this is actually a linear combination. So you get 0. So these a n, the second integral, a sub 0, as well as the integral from negative L. The a n's here go from 1 to infinity, of k, and then the b n's here go from 1 to infinity. These are now in this case that are being multiplied by cosine of n pi x over L and sine of n pi x over L. Then what this is equal to is the integral from negative L to L this form. Of cosine of 0. The question is, how do we calculate the integral is just a n's and b n's? So we're looking for a formula for, on the other hand, if k is not 0, b n's, in terms of then to evaluate this integral f. So in other words, you have some function that's written in this form. What do you do with your function to calculate the a n's and the b n's? Substitution in terms of f. So you could let the idea is be k pi x over L and then do a substitution. So that's what we're looking for. So the idea is to integrate, if you can easily do this, both sides from negative L to L. And what's going to happen is we've seen that over when you have these integrals, a lot of them will be 0 times sine, and that's going to simplify things a lot. X over L. So that would be the antiderivative. First, I'm going to calculate a sub 0 from negative L to L. Integrate f from negative L to L. So here we're just using. Now we're going to integrate the right-hand side. That when you do an integration, like if you have the integral of a sub 0 over 2, and then plus ax, the integral of the sum, be 1 over a sine of ax. And this is going to be the sum plus c. So I can distribute the... That's just from doing the u substitution. So when you have a substitution where it's just u equals the constant times x, the integral of a sum, that's the sum of integrals. So it's the sum from n equals 1 to infinity of a sub n times the integral from negative L to L of cosine of n pi x over L dx.
Integral.
And then plus the sum from n equals 1 to infinity of b
So
sub n
now
times
you have
the
this,
integral from
and then
negative
this
L
is
to
going
L
to be
of sine
L over k
n pi x over
times sine.
Well, we know that
substitute
these integrals,
x equals
so now
L,
this
so you're
is
going to get k
where
pi,
we're going to use this integral
and then minus
facts
from the previous
sine
video.
We know that this
of
integral of
negative
sine
k
is 0, and this integral of cosine is also 0.
Well, k pi, if k is
And
an
this is-
integer, then k pi is a multiple of pi, and so sine
this
is going to be 0.
important that
And so you're just going to get 0.
n here in this integral
Is greater than or equal
So
to
if
1.
k is not 0, this
So,
integral is
actually,
just
this
0.
integral
So
is
this-
just
the integral of a
integral
sub 0 over
is
2. Well, that's just a constant, so
2L
we're going to get the constant times
k
the
is
length of
0
the interval.
and is 0, then
It's
k is
this
not 0.
times 2L.
That's
Now
what
the
we
2's cancel, and
found.
so you get, whereas the integral above is just always 0 no matter what the
Value
L
of k
times
is.
a sub
So
0.
let's write this down.
So
this
that
one,
tells me,
And we have
right,
this one.
because this integral is L
These
times
integrals
a sub
are
0.
going to be important
So you're going to divide
when
both
we're
sides
talking
by
about
L,
Fourier
and get a sub
series.
0 is 1 over L times the integral from negative L to L of f
So
of
these are
x
the first two.
dx.
Those are pretty basic. Then the
So let's
third
put that in the
one
box.
is also pretty basic.
That's a
because
sub
you have
0.
to integrate
If you
from
want to find a
negative
sub
L
0,
to
you
L,
integrate your function
of
from
sine
negative L and then
pi
divide by L.
x over L times cosine n pi x over L.
Now we're
dx.
going to try to find
And m and n are integers
sub
that
m,
are greater
where
than
m
or
is
equal
greater
to
than or
1.
equal
to 1. Well, here, so we went over the fact that sine
the
of m
idea
pi
is
x over L, that's
there's
an
a
odd
trick.
function.
So to do this, we are going to multiply
And similarly, cosine of
by
n pi x over
cosine
L is
of
an even
n pi
function.
x over L, and then
I'm just going to write out
Integrate.
how to quickly check that this is an even function.
it's not obvious
So
why
cosine
we will
of
do
n
this.
pi x over L is an even function because
But
when you
once we do
replace
it, we're going to see that a lot of things
x by negative
will become
x,
0, and things are going to simplify a lot.
so this is going to be cosine of negative
So we
n
do
pi
it
x
to both
over
sides,
L.
so we
I
get
just take
the
cosine.
integral from negative
Well,
L
I
to
just take the
L
minus sign out.
of f
but
of
still
x
inside the
times
parentheses.
cosine of m pi x over L dx equals.
And then,
Well, this a
We
sub
use the
0 over
same
2 when you multiply
idea
by
that
cosine
if you
of
take
n pi x over L
to be
move that
theta,
constant out,
cosine of negative
so you get
theta
the
is
integral
equal
from
to
negative
cosine
L
of
to
theta,
L
that's
of
our cosine.
cosine of m pi
And
x
so you're just
over
going to get
L,
cosine of n pi x over L.
and then you're
So
going to
when you
get
replace
plus
x by
the
negative
sum
x, you actually
from
get the same
1
function.
to infinity of a
So
sub
that
n
means that you have an
times
even
the integral
function.
from negative
And we
L
know
to
that
L
the odd
of
function, so I
cosine
have an
of
odd
n pi
function
x
here,
over L times
okay,
cosine
times
of
an
m
even
pi x
function.
over
So
L
the
dx.
product of an odd function
Okay, where
with
does
an
this
even
come
function
from?
is an odd
Because-
function. And so what is the
Because
integral?
I'm multiplying
It's 0.
this sum by cosine of m pi x over L, and I'm distributing
So that's
the
the
cosine
third
of m pi
property.
x over L inside
The third integral
each
that
of
we're
these
looking
terms
at.
that's being added.
That this
So I get
integral
this,
of a
and then
product
I'm
of
doing the
sine and
integral.
cosine,
So that's how I'm getting this.
sine of m
And
pi x
then
over L
I
times
get
cosine
plus
of
the
n pi
sum
x over
from
L.
n equals 1 to
That the
infinity
integral
of
from
b
negative
sub
L to L
n
is
times
0.
the integral from negative L to L of sine n pi x over
And now
L
we're going to
times
look at what happens
cosine
when you
n
have
pi x
sine
over
times
L.
sine and cosine times cosine.
So now we
those
are
the
going to
last
use
two we're going to look at.
our integral
So
facts again.
now we're going to figure out the integral from
Because
negative
now
L
we
to
see
L
that
of
this
sine
integral
of m
is
pi
just going
x
to be 0.
over L times sine of n pi x over L.
Okay, and because m is at least 1, and then this integral here
in the previous video we went over is product to sum formula.
0,
And there's a
if m
formula
is
for the
not equal
product
to
of
n,
two sines. Sine ax times sine bx.
and it's
And
equal
I'm
to
just going to
L
use the formula
if
here.
m is equal
And when
to
you use
n.
the formula, you end up getting, okay, so you replace this product of sine using the product to sum formula.
Okay,
Use the product to sum formula.
is that correct?
Yes. And then you're going to get a sum, and then you can
similarly this
integral.
one.
And when you do that, you get
Well, actually, isn't this one 0?
1/2
Yeah, this one is 0.
outside. Okay,
So
because you have something divided by 2.
we are
so I just
going
wrote
to
it as
get
1/2 times. The
we
integral from negative
simplify
L to L of cosine
that
of m minus n,
the integral from
pi
negative
x
L to
over
L of f of x
minus the
cosine
integral
of
from
m
negative
pi
L
x
to L
over
of
L
cosine
is
of
equal
m
to
plus n pi x over L.
so in this so this whole sum is just going to be 0. Because
now
you're
let's
just adding a
say
bunch of
that
zeros. This whole thing is
m
0.
is not equal to n.
Now this sum,
Well, now we see that we have an integral.
you're adding
of
0
cosine.
if m is not equal to n. And so the only thing left in the sum that's not 0 is when m equals n.
You usually don't have to write parentheses.
So I'm going to get,
I'm just going to write it like this. So if
A
m is not equal
sub
to n, then you get cosine of some
m
integer pi x over L. Right? So
times
my m
this
minus
integral,
n,
which
would
is
be like
L.
my k
So I
here.
get a sub
So when
m
you
times
have this
L.
integral, we went over the fact that it's going to be,
Wow.
if k is not
So
0,
now
then
I can
this
just
integral
divide
is
both
just
sides
0.
by L and get that a
So-
sub m is equal
And
to 1
similarly
over
on the
L
right,
times
if you
the
take
k
k
to
to
be
be
m
negative
plus
n,
L to
then you
L
get 0.
of f of x times
m is not equal
cosine
to
of
n.
m pi x over L dx. And m and n again are
This is when m
positive
is greater
integers.
than or equal to 1.
So if m is not equal
However,
to n,
notice
that when m is
you
equal
just get
to 0, okay, a sub 0. So
And this whole integral
this
is
formula actually
On the other
is
hand, if
correct
m
when
is
m is
equal
0
to n,
also, because if
then
m is
what
0,
we end up getting is
then you get a sub 0 here. If you plug in
1
m equals
half
0
times
here,
the
you
integral
get
from negative L to
cosine
L.
of 0, which is 1.
1 over
So
L
then you
times
would
the
just get
integral
0
of
so you get
f from
cosine
negative
of
L
0
to
is
L.
1.
And then minus
And
the
that's
integral
exactly
from
what we
negative
found
L to
here.
L.
So actually,
Well, this thing
this
here,
formula,
okay, it's going to be 0, right? So this part is 0
by
for the same reason
the calculation
as above.
and so we just get
1 half
a
times
0
the integral
above.
of 1. Well,
This
that's
formula
equal to 1
actually
half
works.
times 2L.
And so that's just equal to L.
This formula holds for all integers
This
m greater
integral
than or equal to
is
0.
equal to not just m greater than
0
or equal to 1.
if m is not equal to n.
In other words,
and
it also
L
works for m equals
if
n.
m equals n.
And that explains why we used a sub 0 here, the a sub 0 over 2.
Now there's one more integral, which is when you have cosine times cosine.
It just makes the formula nicer to
So-
work with. So you don't have a different formula for a sub 0 and then
The last
another
one
formula
is
for a sub
the
n
integral
when
from
n is
negative
greater
L
than
to
or equal to
L
1.
of
You can just use
cosine
the same
of
formula
m pi
for
x
all
over L times cosine
the
of n
integers
pi x
from
over
0 to
L.
infinity. Again, m and n are positive
so this
integers.
formula is actually
and we're going to use
true
the
for
product to
all
sum
formula again. So this is going to
m
be 1
greater
half
than or equal to 0.
times the integral from negative L to L of cosine
So that's the a sub m.
of m minus
Now we need to
n
find the
pi
bm.
x over L.
So to find the bm's,
dx
we do the same
plus
thing.
the
So
integral from negative L to
notice
L
that
of
for
cosine of m
bm's, there's no
plus
b
n.
sub 0. It just starts from b sub 1.
Pi
Now, instead of multiplying by cosine, it turns out that what
X
works
over
is to
L.
multiply by sine.
So multiply, is that true? By
Hopefully this is
sine
true.
m pi x over L. So
Pretty
multiply
sure
what
this-
by
so
sine
these are
m
these
pi x
basic
over L?
trig facts.
Multiply, you
And
take this
they'll
this
be
thing
used
here,
in
and you
calculating
multiply both
the
sides by
Fourier
sine m pi x
coefficients,
over
which we'll
L,
talk
and
about
then
in
you
the next
integrate
video.
from negative L to L.
So it's the exact same thing as we did to find ands, except instead of cosine, we use sine.
So we multiply both sides by sine m pi x over L, and then integrate from negative L to L.
And when we do that, we are going to get
On the left, the integral from negative L to L of f of x times sine of m pi x over L dx.
And then on the right, you're going to get a sub 0 over 2 times the integral from negative L to L of sine m pi x over L dx. And then plus the sum from n equals 1 to infinity of a sub n times the integral from negative L to L of cosine n pi x over L times sine of m pi x over L dx. By the way, in case you're wondering why do I write the parentheses sometimes and not other times, there's no reason. Okay, it's just if I feel like it. And then plus the sum from n equals 1 to infinity of b sub n
times the integral from negative L to L of sine n pi x over L times sine of m pi x over L dx. And now, once we're here, we use those integral facts that we saw before. This integral is 0, right? It's the integral of an odd function from negative L to L. This integral of sine and cosine is going to be 0. And this integral here is going to be 0 if m is not equal to n, and L if m is equal to n. And so, I mean, it's kind of almost magical that basically everything cancels. Everything is just 0 except for one term left. And this is just going to be what you get when you take the term n equals m here. Well, if n is equal to m, okay, then we get b sub m here, and then you get this integral, which we found is equal to L. So you just get b sub m times L is the integral from negative L to L of f of x cosine m pi x over L. And so, therefore, we conclude that b sub m is 1 over L times the integral from negative L to L of f of x times cosine of m pi x over L. No, it's not. Sorry, did I sign? Oh, yeah, it says sign here. I just copied my notes wrong. This is going to be, okay, let me just write it again. So it's sine m pi x over L dx equals this. So this is going to be sine. So this is for all m greater than or equal to 1. So let's put this in the box. So that's the formulas for the AMs and the BMs. If your function, oh wait, no, this is from the previous video. Where did we start? We started here. So let's summarize what we did. So we said, suppose that you have a function and it looked like this.